Welcome back. Let's continue now and make an overview of Entity Framework. What we'll see in this lecture will be first we're going to make an overview of Entity Framework. We'll see some Entity Framework features. We'll go through basic workflow. We're going to take a look at components, and we will see a simple diagram of runtime metadata. So, basically, Entity Framework is standard ORM framework, part of .NET. We already know what ORM is, so I guess that's fine now. It provides a runtime infrastructure for managing SQL-based database. The relational database schema is mapped to an object model, classes and associations. Visual Studio has built-in tools for generating entity framework, SQL data mapping, etc. So basically data mappings, they consist of C# classes and HTML. And basically a standard data manipulation API is provided. So maps, tables, views, these are some of the main features, which are maps, tables, views, store procedures, and functions as .NET objects. It provides link-based data queries. This is executed as SQL select on the database server. We got built-in CRUD operations, like we got create, read, update, and delete. And all that is coming built-in, so we're not doing any advanced code to make it work. As well, we can create or delete database schema. It can also track changes to in-memory objects. After that, basically it works with any relational database with valid entity framework provider. This is basically our very big benefit, that using entity framework we can work, for example, with Microsoft SQL Server, we can work with MySQL, we can work with SQLite as well. So it works with visual model, database, or with your own classes. Now with Entity Framework, you can have visual model. This thing is basically generated in Visual Studio, something like tables. So that's like in Microsoft SQL Server, but let's say it in Visual Studio. And this is called model first. So we have model first. After that, the other thing is database. Here, basically, we got it generated in our, let's say, management studio. And this approach is called database first. The last one is with your own classes. So here, this one is generated actually in classes. So here we got simple.cs, which are C# classes. And this thing, the approach is called code first. So what we have model first, we have database first, and we have code first. In this course, the only approach that we will review is code first. Why? Well, because database first and model first are deprecated. In the last version of Entity Framework Core, they removed database first and model first. So there is no point of studying something that it's already deprecated. That's why we're trying to point to the incoming technologies and current technologies. So currently, Entity Framework support only code first. We can speak a little bit about model first and database first, explain what that is, but we will focus on code first. So it has basically very good default behavior. It's very flexible for more granular control. It's also open source, independent release cycle. I place here 2 links which you can explore, and also you can explore in GitHub Entity Framework open source and see how it's actually coded, which is pretty interesting. Now let's continue with basic workflow. So what we're doing, first we're defining our model. This is done by code because, as I already said, to do it in database or Visual Studio Designer is already deprecated. So the first step is define the model with code, which means create C# class. Express and execute query over iQueryable. So basically, after we got our class, we need to execute query, right? And then this is done through iQueryable interface. After that, Entity Framework determines and executes SQL query. So here what we have is from simple link, which is this link, and it's returning iQueryable. When we're making the query, it's converted to SQL native query. So basically that's what's doing. It is getting some link and convert it to SQL. Entity frameworks after that transform selected result, so the result from our SQL query, which is executed on the server, the result has been transformed into .NET objects. So once again, we got our model, which is C# class. When we would like to execute something, we're basically doing it with link, which is returning iQueryable. With that link, after that, it has been converted to native SQL query. After that, this SQL query is executed. After that, we get some results and we convert database results to C# objects. Okay, after that we modify and call save changes, because that's a method inside our DB context. We'll speak later about DB context, but we're saying save changes to save so far changes. And Entity Framework determines and execute SQL query. Okay, now let's go through Entity Framework components. So we got the DB context class. What's the DB context class? Well, this is like wrapper. You can think of it like container of all tables, which are actually all models. So let's say in your database, you got table people, you got table, let's say houses, why not? So you got one database with two tables. Now, how this will look in as code? Well, you have DB context, and inside this DB context, you say I'll have public IDB set, that's the way to define it, people. And after that, public IDB set from houses. And actually here will be house. Okay, so what's DB context? Well, you can think of it like container or wrapper for all your models. So all your models now looks like C# classes, and you need to add them somewhere to say that this model is for this database. So you add it in DB context. It basically holds database connection as well at the entity classes. Provides link-based data access, because when you add something inside your DB context, first, how does it look like? Well, you have public, let's say app DB context, which inherit DB context. Okay, here you got some constructor for which we're not going to speak now. What does it receive? App DB context, let's say something. And after that, what you have? You have public DB set from name of your table, person. And you got here after that the name of property, people, get, and set. After that, public DB set from car, and you got cars, get, set. So when you access let's say app DB context dot people, after that you can say, for example, dot find. You can say dot add dot save changes. So after you access this, which is from type DB set, you got basically it's returning iQueryable to the end, so you can apply any link-based queries. It implements identity tracking, change tracking, and provides you the API for CRUD operations. How I already said, you can say var app DB context is equal to new app DB context, and after that you can say app DB context dot people dot add, and here you give new person. the class. After that you say app_db_context.people, and what you want to do is save changes. So .save changes. Why? Well, because if you leave it only with add, it will be like you wrote the query but you didn't add it. So we got the first main component is db_context. After that we got the entity classes. Each database table is typically mapped to a single entity class, as we already know. We got associations, which is basically relationship management. An association is a primary key, foreign key based on relationships between two entity classes. So here we got one to many, many to one, we got one to one, and many to many. So now here we got relationships as associations. It allows navigation from one entity to another. For example, I can say again var app_db_context is equal to new app_db_context, and here say var people is equal to app_db_context.people.toList, or let's say I can say .first or default, and I would like to get only one person, so this will be var person. What I can do after that? Well, I can say person.cars, and I receive .cars as a simple list, a simple collection inside my class, but basically this is coming from relationships. That's why you can access it. If it's one to many, each person can have multiple cars, then I can say on this person.getCars. So it's pretty easy. We got concurrency control. Anti-framework use optimistic concurrency control, no walking by default, but you can still walk it if you need. It provides automatic concurrency conflict detection and means for conflict resolution. So the last thing that we're going to see is anti-framework runtime metadata. So we got some conceptual model schema, and after that here we got our mappings, which goes to database, structure, schema, and database. After that, from our database, it goes again to database, structure, schema. So from model schema we get database, and from database we can have conceptual. All this is done by our ORM, which executes the mapping. So in map the DB context, for example, to this table, because you provide a connection string, we're going to speak later for connection string, and it generally map the models. So map XX table with XX C# class, together with properties, fields, and everything that is public. Thank you very much for watching. I hope that you understand some basics from Entity Framework. In the incoming lectures, we're going to review it more in depth, and we're going also to go in Visual Studio and write some code. Thank you for watching.